So today we're going to figure out how to do enthalpy change of neutralization. So after this video, we're going to figure out how to do all the same type of question. And let's take a look at question 1. So question 1, off the top of our head, we'll see determine the enthalpy change of neutralization. So this first step we're going to do is to identify the reaction here. So what is the reaction here? So we have NaOH and H2SO4. So the reaction is going to be like this. All right, so second step is, what does the question want? Obviously, it wants enthalpy of neutralization. So enthalpy of neutralization is always negative. And the reaction, the equation we need for this enthalpy is, of course, plus minus delta Q divided by N, where more specifically, it's not plus minus here. It's minus because we said it's smaller than 0. And delta Q. The N is, of course, water because it's neutralization reaction. So the next step, we're going to find what we need. Obviously, it's Q and NH2O. And let's go to the next step. Next step is to find what the limited reactant is, which is LR is short for limited reactant. And the first step we're going to do is, let's see how many substance we have here. So 50 cm cube of NaOH and 50 cm cube of H2SO4. So total volume equals to 50 plus 50 equals to 100 cm cube. And because we assume the density of this mixture equals to the density of water, so total mass, and namely, which is 1 g cm cube. So total mass is 100 gram for sure. And in regard to limited reactants, the NaOH mole is its volume times its concentration. We can see from here is 2.0 mole per dm cube. So equals to 50 times 10 to the power of minus 3 times 2 mole per dm cube equals to 0.1 mole. And similarly for H2SO4, luckily we have the same concentration, so it's also 0.1 mole. However, we can see from the reaction here, its mole ratio is different, so it's 1.2. 1 to 2 equals to 1 to 2. What does it mean? It means for 1 mole of H2SO4, it needs only 0.5 mole of NaOH to react. Similarly, we have 0.1 mole of H2SO4, so we only need 0.05 mole of NaOH, which is actually smaller than what we have here. That makes H2SO4 the limiting reactant. And our next step is to find the mole of an H2O. And from the stoichiometry relationship, we can see that the mole number of H2O is equal to NaOH. So what we have here is 0.05 that reacted. So it's also equals to the mole of H2O. And now we're going to go to the next step, which is to find Q, because we also need Q to find the enthalpy. And we can see from the question here that the initial temperature of two solutions are different. So the initial temperature of the mixture is 17.5 plus 17.9 divided by 2, which is 17.7 degrees Celsius. So the total change in temperature equals to 32.0 minus 17.7 equals to 14.3 degrees Celsius. And we also assume the specific heat capacity of the mixture equals to water as well. So C also equals to 4.18. The unit is joule per G degrees Celsius, of course. And then we just substitute all this into the equation. Q equals to C times M times change in temperature. 4.18 times 14.3 times 100. We get 100 from here. Total mass equals to 5977.4 joule. So change in enthalpy equals to minus, don't forget this, 5977.4 divided by 0.05, and you'll get the answer. In this case, which will be minus 119548 joule per mole. And that's it.